Hello students, welcome to lesson 3.2 on adding, subtracting, and multiplying polynomials. So how do we add polynomials? Well, we always look for like terms, right? So we're looking for the same variable raised to the same power, and then we combine the coefficients. So I have a 6x cubed and a 2x cubed. When I add those together, I get an 8x cubed. So we're only adding coefficients, right? The powers do not change. And we want to stick to our standard order. So next I'm looking for if I have any x squared terms. I have x squared and I have minus 8x squared. So that gives me a negative 7x squared. And one thing you might want to do is sometimes cross these out so you know that you're done with them. Next, I'm looking for my linear term, which is the x to the first power. I have a 4x here, and I don't have that term here. So that just stays a 4x. And then lastly, I have my constants. So I have negative 7 plus 3, which gives me negative 4. So there is the addition of the two polynomials. Now, subtracting. When we subtract one polynomial from another, we need to remember to change all of the signs. So that's the first thing I'm going to do. I'm going to go through and distribute that negative sign. So I have minus x squared y squared minus 3xy squared and plus 2x squared. So now I have two variables. So what I'm looking for is the same variables to the same power. So I have a 3x squared y squared. Over here, I have negative 2x squared y squared. So again, I combine the coefficients. 3 minus 2 gives me a 1. So it's x squared y squared. Right? We don't write the 1 just like we wouldn't write a 1x. Okay, so let me cross out those two terms. Done with those. Now I have a 2xy squared and a minus 3xy squared. So that becomes minus xy squared. Again, notice the powers are not changing. All we're doing is combining coefficients. And then I have a 6x squared and a plus 2x squared. So that becomes 8x squared. So always distribute that negative first, then look for your like terms and combine the coefficients. Example 2, multiplying polynomials. So when we multiply, what we're going to do is the distributive property twice. First, I'm going to distribute the 2m over all three terms. Now I have m times an m squared. Remember, our rules of exponents, when I have like bases and I'm going to raise, excuse me, I'm multiplying them. So I have a base to a power. I'm just going to generalize. Actually, let me use an a. So if I have m to the a times m to the b, from our rules of exponents, we add these exponents together. So this becomes m to the power of a plus b. So as long as I have the same base, right, it has to be m and m, couldn't be two different variables. I can multiply, the base does not change, and what I do is I add the exponents together. So here I multiply the coefficients, so 2 times the 3 gives me 6, and m times m squared, right? It's the same base, m and m. I add the exponents, so this is an exponent of 1 plus 2 gives me m cubed. Now I'm going to distribute the 2m over minus 4m. So I have minus 8 when I multiply the numbers, and m times m. Add up those ones and we get 2, so m squared. Lastly, I'm distributing the 2m over the plus 2. So that gives me a plus 4m. Now what I like to do is line up my terms in a vertical direction. You can keep working horizontally if you choose to do it in that form. I like lining them up so I can just then combine and get my final answer by adding up columns, okay, instead of looking across. So that's a matter of preference. Now I'm going to distribute the 5 over all 3 terms. So 5 times 3m squared is 15m squared. So I'm going to put that term right under the negative 8m squared. 5 times minus 4m gives me negative 20m. And 5 times 2 gives me a plus 10. And now I just add in a vertical direction. So I have 6m cubed. Negative 8 plus 15 gives me a positive 7m squared. Again, notice the variables and the powers are not changing because I'm adding. Negative 4 minus 20 is negative 16m and plus 10. So there's my final answer. So distribute, then combine, add or subtract your like terms together. In example 3, I've got 3 different binomials. So I have to start with 2 of them, and it doesn't really look like it's going to make a difference here which 2 I start with. So let's just start with the first 2, and then we'll take care of the third one after. So think of it as FOIL in this case, right? Because we just have 2 binomials. So I'm going to multiply mn times mn. So again, when it's a product and we have like variables, we add up those exponents. So this just becomes m squared, n squared. Okay, so that's my first terms. Then my outers, mn times negative 2 is negative 2 mn. Then my inners, so I have 1 times mn. That's just a plus mn, and then 1 times negative 2. I can add together my middle terms because they're like terms. So minus 2mn plus mn gives me a minus 1mn, but again I don't write the 1. So I end up with a trinomial, and now I have to take care of multiplying by this binomial. So now it's this product, the trinomial, times the binomial, mn plus 4. You can put it here, or if you prefer to put it out front, that's up to you. Okay, let's rearrange it. It kind of looks a little better, I think. It's a matter of preference again, though. It really doesn't matter, right? Whether if it's numbers, if I do 4 times 5 or 5 times 4, doesn't matter which number is in which order. Okay, so I'm going to distribute the mn over all 3 terms, just like I did in letter A when I distribute the 2m over all 3 terms. So mn times m squared, n squared, and we have the same variables, so we add the exponents. So it's first degree plus second degree gives us third degree. Now mn times mn, so that becomes m squared, n squared. And now times the negative 2, so it's minus 2mn. Now I'm going to distribute the 4, and I'm going to line these up again vertically, so it's 4m squared, n squared. So I'm going to put that right here. And then 4 times mn, and then 4 times negative 2. Now I'm going to add in a vertical direction, so it's m cubed, n cubed. Negative 1 plus 4 gives me a positive 3m squared, n squared. And negative 2 plus 4 gives me a positive 2mn minus 8. So when you have more than 2 quantities to multiply, start with 2 of them, get that product, right? That's what we did here. We got this trinomial. Then multiply by the third quantity, and that may involve using the distributive property the way we did, multiplying over all three terms when you have a binomial times a trinomial. Combine your like terms, and then you get your final answer. Okay, let's see. We have a couple of additional examples here. So we're going to use the distributive property first, okay, to multiply the two binomials together, because notice this is not all a product. We have a plus in between. So we have to follow our order of operations. So first we're going to multiply these two, and then we're going to multiply these two, and then combine by adding, right, any like terms that we have. So actually, let me move this out of the way. Okay, so let's start by doing our FOIL. So x squared times x is x cubed. X squared times 1. Negative 1 times x. Negative 1 times 1. So just stick to an order, right? FOIL is usually best when you have two binomials. Then this plus symbol comes down in between, and I'm going to do FOIL here as well. So 2x squared times 3x. 2 times 3 gives me 6. X squared times x is x cubed. 2x squared times negative 7 minus 14x squared. 4 times 3x. And 4 times negative 7. And now I combine like terms. So I have an x cubed times a 6x squared, 6x cubed, or plus, did I say times? I don't know. So I get 7x cubed when I add those two together. X squared minus 14x squared is minus 13x squared. That's done. Negative x plus 12 plus 11x, and minus 1 minus 28, so negative 29. Okay, for our second example, notice that this is a minus in between. So once I multiply these two quantities together, I'm going to have to remember to change all the signs. The nice thing with this one is here we don't have two binomials, I just have a 4a. So I'm going to distribute that 4a over both terms, and I'll be done with that product. So 4a times 3a cubed, 4 times 3 is 12. A times a cubed gives me an a to the fourth. Right? Remember, we're adding exponents when we multiply like bases. 4a times 2a squared gives me a positive 8a cubed. And now I'm going to bring down that minus symbol, and I'm going to do FOIL with these two binomials. So 6a squared times negative a cubed. So that's and I'm going to put a parenthesis or a bracket here. I'm going to use a bracket because I don't want to confuse. I'm going to just work with these values. I'm not going to worry about this minus symbol until later. So bring that down in front of your parenthesis or your bracket. So it's 6a squared times negative a cubed. So that's a minus 6. Add the exponents. A to the fifth. 6a squared times minus 5a. So that's a negative 30. A to the third power. Now I'm going to distribute the 7. So 7 times negative a cubed is negative 7a cubed, and 7 times negative 5a is a negative 35a. Okay, my next step now, I'm going to take care of this subtraction symbol. I'm going to distribute, think of it as distributing a negative 1 over all three terms. So I have a minus times a minus. Negative times negative gives me a positive 6a to the 5th. Again, all my signs are going to change. So since they're all negative, they're all going to change to positives. Oh, and I can combine these two. So actually, let's back up a minute. We have like terms here, right? We've got a negative 30a cubed and a minus 7a cubed. So that's a negative 37a cubed, which becomes a positive 37a cubed. And then I can change this sign to a positive 35a. And bring down my first two terms. 8a cubed, and let's put this in standard order. So our first term, here it is, right, the one with the highest exponent. So we have 6a to the 5th. Okay, done with that. Then a 12a to the 4th. Done with that. Then I can combine these coefficients because they both have a cubes. They're like terms. So that becomes 45 a cubed. And lastly, I have the 35a, which does not have a like term. And there's my final answer. So when you have a combination of products and adding or subtracting, we do the products first. Okay, if it's a sum, you just combine all your like terms if you have any. If it's a difference, distribute that negative symbol over all of these terms and then combine your like terms. So that concludes this lesson. I hope you enjoyed it, and I'll see you in class.